16 is going to look like this. Okay, so this one's a little bit different. We're still going to create an input-output table and figure out what the rules are. But instead of doing strings and cuts, we're looking at these three figures here, and we're looking at the number of small squares in each figure. Okay, and there's a pattern that's going to take place. So for A, it says find the number of small squares in each of the big squares shown. Okay, so we've got to do that first. So in figure 1, how many small squares do you see? Okay, I'm hoping you only see 1. For figure 2, how many small squares do you see? I'm hoping you see 4. And for figure 3, how many small squares do you see? Hoping that you see 9. Okay, so for A, this is what we're looking at. Figure 1 had 1 small square, figure 2 had 4, figure 3 had 9. Okay, that's going to be important when we set up and organize our table. All right, so B is going to say organize your information in a table. What do the variables in your table represent? All right, so I use X and Y a lot, and you know, it doesn't really matter what variables that you pick, but just for the purposes of this lesson, stick with me, the ones that I pick for you. So for our table, we're going to use F as a representation of the figure, and then S is going to represent the small squares. Okay, so all I've done is I've created and organized it in a table. There was figure 1, it had 1 small square. Figure 2 had 4 small squares. Figure 3 had 9 small squares. So go ahead and make sure that you have this table written down under B. Now, while you have this, I want you to think about, again, that rule, that relationship of what is happening between 1 and 1, 2 and 4, 3 and 9. There's something taking place every single time between F and between S. Okay, because C is going to ask us what relationship do you see? And that's when we're going to set up our rule. So I'm going to give you just a second to think about what could be going on between F and S. Okay, if you were thinking that F, okay, is timesing it by itself to get S, you would be correct. Okay, so for C, it's going to ask you, what do you see? The rule here is going to be F times F equals S. So you are timesing the figure by itself, its number, to get the number of small squares. Okay, that's going to be under C, the relationship. And since I know this relationship now, it can say, well, how many squares would you have in figure 4? So now I can apply that. How many squares would you have in figure 4? So I've done figure 1, 2, and 3. If I had figure 4 here, how many would it be? Okay, and you should have been thinking 4 times 4 equals 16 small squares. Okay, all right. For D, it's going to say, in your table for each figure number, write an equation that shows a relationship between the figure number and the number of small squares in the big square. So it's just wanting you to take it and write them in equations to prove that our rule was correct. Okay, so for example, for D, here are my equations to prove that rule. There's figure 1 times itself gave me 1 square. So we're writing this down under D. There's figure 2 times itself, we have 4 squares. There's figure 3 times itself, we have 9 squares. So this is an example of applying the rule, showing it in an equation, making sure that it works. Okay, and E is just going to tell you to say this in words. Okay, so for E, pretty much what you're doing is you multiply the figure number times itself to equal the square numbers. Okay, that's what we did. So with E, you're just putting this rule into words. You multiply the figure number times itself to equal the square numbers. Just like with lesson 15, we use different variables. I used F and then I used S, okay? So again, why did I do that? Why did I not keep the same exact? Now, I will tell you, some of you might say, yeah, but you did keep the same exact when you said F times F, and you're right. That indicates to me that that's the same variable, F times F, but then I also changed it to equal S, so that's going to show that it's a different value. So for F, we did use different variables, again, to represent different values. I am very well aware that we did keep F the same twice, okay, and that's good if you recognize that that was the same. So you should know that that represented the same value. However, when we did equal it to S, it changed. Okay, it did change. And then G's going to say, why do you think your rule represents this relationship? Can you explain it by context? Well, again, we tested it, didn't we? Okay, so the rule applied to all that were tested. So we did that whole F times F equals S, and it worked. Taking the figure, timesing it by itself, gave us the number of squares. So that's how it worked. We made sure that it went through and it did every single one, and it worked. So the last one is going to ask, what if you had a figure 15? How many small squares would you have? Remember, if we apply that rule, we're going to say 15 times 15. We're going to end up with a lot of squares. So for that final H, 15 times 15, if I multiply that out, that 2 by 2, I would get 225 small squares in that figure. Okay, and this concludes lesson 16. So again, if you have to stop and rewind, because I know I go through this pretty quickly, but if you have to stop and go back and rewind and review parts of this video again so that you can have it written out on your sheet, that's fine. Once you finished it, you need to turn in your assignment to the sub, and then they will give you the directions for what comes next. All right, thanks.